Welcome back. This is the PDF. This is the material that we'll be using. For now. Actually, I won't be able to explain much on this much from this textbook, because you just be using it as a side material. It's not the main material, so you will need to be reading it by yourself most times. So just start reading it from the beginning, be simulating the circuits, and be modifying the circuits to do one or two things that are not mentioned in the circuit, in the material that you think that it is possible for you to do with the circuits. So because electronics is very dynamic, so I will send the PDF. Now let's go back to the simulation and to the explanation on circuits on transistor. Okay, so now let's start with NPN. After that we'll use PNP. NPN, to use it as a switch, you will need, this is a circuit, right? So current flows from higher potential to lower potential, from positive to negative. If you want to use instead of using this manual switch, if you want to use electronic switch, if you want to transistor, you want to use NPN, to be precise, NPN as a switch. You connect this point, this lead, which is the connector, you connect it to the most positive side. Firstly, how do you identify the connector, the base, and the emitter? You have three pins. You have collector, base, and emitter. So for MOSFETs, we have for MOSFETs and for FETs generally we have gate, drain, and source. And for BJT we have collector, base, and emitter. So how do you identify collector, base, and emitter? You can use your multimeter to identify the pins, and you can also search it on the internet. So when you buy a NPN transistor or PNP transistor or FET or MOSFET, just type the name. For example, one of the most common transistor is BC547. Just type it, BC547 pin out. So it will bring out the picture and label it. You will see how it labels it. So with that you'll be able to identify the the collector, the base, and the emitter pins, if you're getting it. So for the sake of simulation, we already labeled it there. So now you connect the collector to the most positive side if you're using NPN. So you connect the emitter to the most negative side. Then if you use it in this circuit, okay, let's break this circuit. Okay, yeah, let's rotate it. Okay, so connect it and connect this. Let's remove the switch now. Remove. This is the collector. It connects to the most positive side, right? So and this connects to the most negative side. Hope you are getting it. So if you switch it now, it won't work. Because for a transistor to work, if that transistor is BJT, you must apply current to the base. The current must reach certain level, because before the transistor will switch on. For now, the transistor is switched off, just as if the switch is opened. But if you apply current to this point, the LED, the transistor will be switched on. Let's apply. But before you apply current to it, because something base current. So base current is what to apply to this transistor, to the base, that make the transistor to switch on. but the current must be controlled. The current must be controlled. You can't just connect it to like 5 volt without any resistor, to any voltage without any resistor, so it will affect it. So you need to control it. Okay, let me for you to understand what I'm trying to say, let's go to explosion. Okay, explosion. So play it now. Nothing will happen, right? So but let's stop it and connect the base directly to positive. So okay, explosion. I don't think this is installed. Okay, explosion supposed to explode. So there's something wrong actually. Let me check. So it works. So but in real life you connect it like this, the transistor will get damaged. So you need to use a resistor to limit the current. But the universal value that you can be using without calculation, so it's 1k resistor. So you can be using a 1k resistor. So put a resistor here, connect. Okay, and this point connect. So this is the perfect configuration. You must use a resistor between the signal and the base. So this is how to connect resistor to the transistor to the circuit. So this thing doesn't make sense at all, because it's like you are repeating the same thing, but it will make sense to you. So the main purpose of connecting this point to this point is to get a current to move through the base, right? So the reason why we connect the base to the positive side is that the transistor that we are using is NPN. If you are using PNP, you won't connect it like this. If you are using PNP, you will connect emitter to the most positive side, and you connect connector to the most negative side, opposite of this. And you connect, instead of connecting base to the positive, you connect base to the negative for PNP. So we are connecting it like this because we are using NPN. Okay. So try to connect it with PNP transistor, and let's see how it looks like, and simulate it by yourself. Okay, so now let's use this circuit. Let's use fully divider with this circuit to make it more meaningful. Okay, I've connected a LDR and a resistor together to make a fully divided circuit. If you have not come across these circuits before, try to check our previous video. You will see it there. We've explained it with some examples. So I connected it together to make a fully divider. So now now I've played it already. So now the LED is not coming up. The output, the V out is what I used to switch the transistor. So now the intensity of the light is high. During the day, the intensity will be high. So when the intensity is high, the resistance of the LDR will be reduced, and during the night, when the intensity of light is very low, the resistance of the LDR will be increased. So since we used the LDR as R2 in this fully divided circuit, fully divided network, the the LDR, the output, the V out that is going to the base of the transistor will be high, at night, and will be low during the day. So now the intensity is high, so there is no out, the output is 3.5, so the current that will pass through this resistor to the base will be very minimal. It will be very small. It will be too small to switch on the transistor. So assuming we are the state of the circuit is during the is during the night. If the circuit is working during the night, it's operating at night, so the intensity of the light will be very small. So with that, the resistance will be high. So as you can see now that since the intensity of the light is very low, the output, the V out has increased to 5.7 from a millivolt. It's moved to 5 point something volts. So okay, so that's when you can use this circuit to build a solar street light, or any other street light, or any light dependent circuit. So assuming you want the circuit to be buzzing at night, so you want it to be buzzing at night, so instead of using this LED, just change to buzzer. You just change to buzzer. So I've changed the LED to buzzer, and I removed the resistor, because we're using the resistor to limit the flow of current to the LED, and we don't need to limit the flow of current for the buzzer. So the current is moving, so it will boost. So that's how it works. So you might be asking yourself that instead of connecting transistor to it, why can't we just connect this output to the LED or to the buzzer directly? It's supposed to work, right? So it will work if the LED is not requesting, or it doesn't need high current. It will work. But if it needs high current, so it won't work. So the reason why we use the transistor is to drive a high current device, high current component like relay. If when we get to hardware programming, we need to be switching a relay or motor with our microcontroller. So we can't switch it directly with the microcontroller. We need to use something like transistor to connect to the device. Hope you're getting it. So to increase this circuit further, so in our next video I will show you how to use relay, so that you can use this circuit to connect your home appliances, like your bulb. If you want your bulb to be coming up at night, maybe your security lights that you put on your fence, if you want it to be coming up at night, I will show you how to do that, and some other things. So like for smoke sensor or for heat sensor, if you want to build a device that will be notifying you when the temperature of certain place has increased, or maybe you have a poultry, you want to be sensing the temperature of your poultry, like if the condition of your poultry is too cold, so it will call your attention. Maybe you light the poultry. So if the temperature is too high, you turn on the fans, something like that. So all that can build it with this circuit. So you can even define that to run those materials or those components like relay or lights or fan. We need to use transistor. You need to use transistor and a relay most times.